Good day, Prof. Today I'll be presenting my final report project. My project is based on the design of automatic water device based on microcontroller. So in today's climate, as climate change is become a very big hot topic in today's time and age, as the world has experienced a lot of drastic change in terms of the climate. Uh, this has also arise many form of pollution in the environment, etc. And this has led to, due to the changing climate, certain areas have had drastic changes in terms of the uh, in terms of the rainfall, um, in terms of the rainfall that they have experienced over the years. As over the years, what has happened due to climate change, the rainfall for season or period has drastically changed, and this has led to a lot of season, dry period in those affected areas, and thus this has led to many plants and wildlife being affected due to this, as there's been a lot of dry seasons, and this has led to a lot of plants not having sufficient amount of water for it to grow. So with this problem being with the climate change, with the climate change causing this problem throughout the world, farmers have also been affected by this drastic change in the rainfall during different seasons, and they have also um, uh, been affected by little rainfall in um, uh, little rainfall during the farming season, and this has led them to manually watering the plants. The problem we're facing today is that many farmers in the agriculture industry still rely on traditional ways of watering the plants. In the traditional way of watering the plants, it's now becoming a very inefficient way of watering plants, where some plants can get overwatered or can get underwater, and that can lead to damages of the plant, and most of the plant of the plant will die eventually. So that's actually hurt in terms of their economics sales. So they had that had with their sales, because they need these plants to be to heal a certain to grow properly and healthy, so that they can have a huge hill at the end of the farming season. So so that is one of the problems that many farmers are facing now. So so to address this problem, to ensure that the plants get enough water and there's no wastage, the best solution is to automate the watering system of farmers. Demo this project to design an automatic watering system based on microcontroller, which and also this system aims to accurately um, provide water to the according to the plant's needs, and to minimize any water usage, and to preserve resources by water efficiency. And lastly, uh, to have the to lessen the possibility of overwatering and underwatering of plants. The objective of this research is to the objective of this project is to conduct research and to choose the the correct technologies and components to meet our target. And the other objective is to create uh, is to develop a a program that will be able to be run by the microcontroller to control the entire system, and lastly to choose the correct components that will help with the design of the system to make everything efficient and affordable. The literature review that was conducted for this project involved looking at relevant projects or information that has been done by other engineers, uh, going through sites like IEEE, going through Google Scholar, etc. So one of the papers that I found, one of the papers that were available was the one done by Ipen Prefono. The 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 title of the paper was Automatic Water System Based on Arduino Board. So in his research, in their research, what they wanted to solve is a solution to help farmers during the dry season when watering the plants. So so the design of the system was to detect the moisture of the soil in moisture of the soil and to water the soil according to the moisture level. So the farmers will not need to water the plants. They will only need to water the plant and they don't need to also plant manually as they used to do. So this what they study showed is that they were able to help automate the watering system of the plants for farmers. The other study was done by Befono Dan Kumara and his associates to design and implement a microcontroller-based automatic plant irrigation system. So, according to the experiment, what uh, the setup for the project was to use a M ATMEGA 32 microcontroller, which uh, the the peripherals which were involved were the humidity and temperature sensor, and they use a motor which was to deliver water from the water reserve to the plants. So in the system, the way the system operated is when there's low humidity but high temperature, the when there's the motor will be turned on, and that will supply uh, that will supply water to the motor will be turned on, that will supply water to the plant and vice versa. If the humidity is high and the temperature is low, then no the motor will turn off and no water will be supplied to the plants. With uh, the result of this system is that the result of the system it worked as the result of the system is that it has several benefits of saving water and plant growth improvement, and making the watering process of plant automatic. The other paper was by by Penham and his associates. This his system involved using a GSM Bluetooth module. He was In this paper, he showed how to make a remote monitoring and automatic watering system. This system involved using a Bluetooth module to receive, control, and monitor the system remotely. And in the system, if the data from the temperature and humidity sensor was sent via SMS to the farmers, so the farmers were able to observe and monitor the farms even anywhere in the world, and they could always get the relative information if the plant is being overwater or underwater, and the system was being controlled by the temperature and humidity levels. And yeah, the majority of this project involves this the block diagram of our system. So the block diagram of our system is the as you can see here on your right, you have the Arduino board, which is connected to the following peripherals. It gets the input from the capacitive soil sensor, and then it outputs the system statistics on the LCD, and then we have LEDs which indicates different states of the system. uh, and then finally we have a MOSFET driver, which is connected to a solenoid valve. The solenoid valve opens and closes according to the system's uh, cap, soil motion sensed by the capacitor soil sensor, and it's powered by a 12-volt power supply. So the power supplies for the other peripherals, which is the capacitor soil sensor, and 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 the LCD is 5 volts. From this diagram, from this block diagram, the the project simulation design was done on Tinkercad. Tinkercad allows us to have to do Arduino simulation, and the circuit is displayed on your right hand side. In this circuit, it's compiled of the same thing from the block diagram. It has the Arduino board. It got some LEDs for indication of the system, and then we have an LCD to visually display any text about the system. We can in the LCD we can get the source sensor reading. We can get the time, date and time if possible, and we can get when the solenoid valve is open and closed. And we have a motto to represent the solenoid valve. Unfortunately, Tinkercad doesn't have a solenoid valve. And then lastly, we have a soil sensor. Unfortunately, Tinkercad also doesn't have any capacitive soil motion sensors. So we're using a normal soil sensor. This is a resistive soil sensor. So the results of the simulation displays the following. So we have this table here that tabulates the results of the simulation. So in the results of the simulation, one we have a soil motion sensor a percentage. We have the DC motor arm position in degrees, and then lastly we have a LED indication. So at low, anything below, uh, any readings below 60, any reading below 80% healed. At low a low percentage soil motion sensor. What we got is that the 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 soil is dry, meaning that it needs to be watered. And what happens next is that the motor is turned, it's opened in 90 degrees, and the green LED the green LED indication is turned on. But however, at high soil moisture sensor percentage, for instance 80%, the 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 motor is turned off, and it's turned off, which is 0 degrees, and the red LED is indicated. Below you can see the graphs of the tabulation. This tabulates the readings of the motor, the reading of the tabulated values from the results. Thank you. Thank you so much for being with me for my presentation. This has been a very good project to get involved in. Thank you. Results of the simulation. Um, so what the according to this table, the result shows that at low water at low uh, soil moisture levels, uh, the the motor is turned on, and the green LED is turned on, and that means that there's the soil is dry and it needs to be watered. At high uh, at a high soil